Now for our next question, we've got quite a few things that we have to answer here. It says we've got to show, and then we've got to answer what the shape is. Now if I just plot the points, then I've got a pretty good idea what this picture is anyway. These lengths all look like they're the same, and this clearly isn't a 90-degree angle. So this looks like a rhombus. But we can't be exact right now because we're not sure if these are exactly the same length. So we're going to have to possibly figure that one out. Show that OR is perpendicular to PQ. So here's OR, and here is PQ. How do we find slope? y2 minus y1 over x2 minus x1. So for the first set of coordinates, if I'm going to do this for OR, then O is obviously 0, 0. And R is going to be 1, 4. So 4 minus 0 is 4. 1 minus 0 is 1. So we've got a slope of 4. P and Q. Oops. So P is 4, 1. Q is 5, 5. And I can use the same formula. 5 take away 1 is 4. 5 take away 4 is 1. And when you divide them, you find out that the slope is 4. Now you should be able to do the same thing with OP and PQ. Sorry, RQ, I apologise. And you should actually find for those that the slope is 1 over 4. Show that OP equals OR, so that means we're going to use the distance formula. So I'm going to just use Pythagoras from this picture so you can check to see if your answer is correct. 4 squares across, 1 square up. 4 squared plus 1 squared is 17. So for part C, you should be getting the square root of 17. Now if I look at O to R, that's 4 up and 1 across. So 4 squared plus 1 squared square rooted, again, is the square root of 17. So they are indeed the same size. Now also we should check in theory what RQ is and also PQ, and we'd find that they are also radical 17. Now our decision is this a square or is this a rhombus with them all being the same length? Now the key is to look at the slopes that we actually found for this question. Now for part 1 we found that the slopes were both 4, and for part B we found that the slopes were 1 over 4. Now if this was a square, that means the angles are 90 degrees to each other, which means that the slopes are perpendicular. Now the key thing about a perpendicular slope is that the slopes will be negative reciprocals of each other. Now it's certainly the reciprocal, but it's not negative. Therefore we know that this isn't a 90-degree angle. Therefore, what shapes do we know that have all the same side lengths, but do not have 90-degree angles? And our conclusion would be for that one, rhombus. So quite an in-depth question, and I was even skipping through parts of that question, but to give you a better feel of what the AICE questions actually look like.